Hello, welcome back to Artist Solves LeetCode, and today we got another question on our hands. I'm gonna see if I can design a minimum stack that supports push, pop, top, and also retrieving the minimum element in constant time. I'd solved this question a long time ago, and I don't particularly remember how to do it, which is the best place we want to be for a video like this. So, taking a look at this, it seems like I think retrieving the minimum element is going to be like the actual hard part of this, because the rest are just normal stack operations that I can do with the Python list, and it doesn't seem like there's any constraints against that. So, if you're not familiar, I'm just going to have a list where you can append to the end or pop from the end, so it'll work like kind of like a stack of plates. So if you put 1, 2, 3 and you want to get the top off, you can just pop the 3 off in constant time. But retrieving the minimum element in constant time is a little different, because you'd have to know where it is. You can't really keep track of that. I'm thinking the right way to approach this is with 2 stacks. It's like when you put 1, 2, and 3 on, you can like add it there too, but I'm not too sure, honestly. Well, let me try and pivot and think about, like, how would I do this in any time complexity at all. Because I can push the values onto the stack, and I could, like, maintain a variable that would hold the minimum value, but I wonder if I could use like a deck where like, oh, but that wouldn't work either. I'm trying to think, because like a variable like min that could hold like at first, well, it could hold 1 in this scenario, and then 2 and 3 wouldn't change it, but then when you get the minimum value 1, then there's just nothing on there, when there should be 2 next. So my next thought was use like a deck where you have 1, and if the next value is greater than, you like prepend, and if it's less than, then you'd append. But what if we go like 1, 2, 3 where you prepend, but then this example doesn't work actually. You go 1, 2, 3, 5, and then a 4 comes, you know, because then you can't prepend behind the 5, but you also obviously don't want to put it there. You need to get it there, but then how would you do that in constant time? I'm trying to think. I mean, in linear time, you would just scan through this. You would maintain this ordering, and every time you add a number, you would scan through the second stack, and then you would know to then put it right at this position. I mean, I can implement that, but that wouldn't be what this problem wants. I mean, what are my options? In constant time, I can either use a stack where you can pop, or like a deck where you can pop from the bottom, or I can use a linked list, or I can use some sort of hashing. A set's not going to work. A dict won't work. I could use a linked list, but I feel like that would be sort of overcomplicating this problem. Let me look back here. I want to retrieve the minimum element in constant time. Oh, wait. Does that not actually pop the minimum element from the stack? Because then if I retrieve, this variable would work because it's just 1, but then until you then pop the entire stack back down. Well, what if I maintained a stack of like just decreasing items? So, let me try this. I'm also getting used to this. Is a new pen. I used to use my mouse, if you didn't notice, which I'm actually pretty good at because I've done that for a while, but the pen, once I get used to it, will be much better. So I'm thinking something like this, actually. So what if I still like the 2 stack idea, because I don't know where I would point any linked lists. So what if we had like a 3 pushed on, then a 2, then a 1? So then in my min, I could put the 3, then the 2, then the 1. And then if a 2 came, I just wouldn't add it at all. What if I like only added? Because then if you want the minimum value in the stack, you can just look at this, and that's fine. And then if you were to pop this, you can see if that is also the, like if it's a minimum value that should be popped from the min stack. Min stack. And then this is just data. I think this would actually work. Because then if you pop this, then you can see it's equal to the min stack. Like check if they're equal. Yeah, I'm liking this. Because then if I pop, yeah, and then I can just go down. But then in the earlier case, where if it's decreasing, increasing, yeah, I kind of like this. Boom. I'm getting used to it. That's too big. Here, let me think of another example, because there's not that many examples actually. I think coming up with these is fruitful. So then if we go decreasing, increasing, we would throw on the 3, 2 is smaller than 3, we'd throw on the 2, 3 we wouldn't do anything. So if we pop this, we check it's not the same, so then we don't do anything to the mid stack. But then if this 3 was actually a 1, then we would throw it on the min stack. I like this. Let's implement this. So in it, we're gonna need our data stack, and we're gonna want our min stack. I think that's it. If we push, we obviously want to append to our data stack. And then we only want to append to the min stack in 2 cases. If it's small value, the value that is coming in is smaller than the top of the min stack, then we want to append it to the min stack. Or if it's empty. So I think that means we can do if not stack or the end of the stack is greater than the value coming in. Or let's do it like this. The value coming in is less than the end of the min stack. Whoa, okay. Self dot data stack. So if there's nothing in the data stack, or the value coming in is less than the min stack, then we want to add it to the min stack. I think this will work. Maybe the check was supposed to be if the min stack is empty, but the min stack should only be empty when the data stack is empty, because the first value, regardless, is gonna be the minimum value, you know? Alright, let's pop then. So this should just be value is self.datastack.pop and return it. Cool, but we have to do something to the min stack. So if the value we just popped is the same as the min stack's top value, then we also want to pop that. And we want to return that value. Awesome. So top gets the top element of the stack. I don't think it actually does anything though. Like, I don't have to pop it, so I can just do top data stack of that. And get min returns, so I think I can, this is where we get to reap the reward of setting up a good data structure for the problem, and this might work. Let's see. No. Oh, I just initialized these wrong. Yeah, I need this. List out of range. Well, I guess you can't check the -1 of the min stack if there's nothing in it. But then shouldn't this have just worked off the first clause? I wonder if this would this trigger? I doubt it, actually. If the first one didn't work, then... Oh, it did! What? But I thought if the data stack was empty, then the minimum stack was always empty. Wait, I gotta get to the bottom of this. Because what that error was saying is if there was no data, it wasn't executing. Oh, but there's always data because I append it. I append it right on top. Oh, that's stupid. Wait, the check should be this. I don't even need that. That's a redundant check. I append right above. Okay. So then this should... Oh. Is the same thing happening over here now? Oh yeah, because you might pop when there's nothing on there. Because if the min stack is empty, then you obviously don't want to do this. So you gotta check if the min stack actually exists. Oh god, I only got through 4. That's not good news. Oh man, I think there might be a lot of edge cases. Or I mean, my problem has just been with these stacks and them being empty, because that's what all my errors have been: list index out of range errors, which is only possible if this is empty, because I'm just trying to access the top. So What should it return if there's nothing in there? Null? I don't see that. Let me look at their... What do you even want here? It's kind of harder to debug these, like, data structure construction questions. But let me try this. If, oh god, I'm using my Python brain here. It actually does guard against the error. Saying it actually expected values though instead of null. That means there might be something wrong with my min stack. Well, what is this question actually doing? Let me break this down. We push 0 on, so it throws 0 on the min stack. We push 1 on, which shouldn't do anything to the min stack. And then we push 0 on again, which actually I don't know what that does to the min stack. I have strictly less than, so that doesn't add anything to the min stack. That probably should. Because if I were to pop the first 0, then there would just be nothing in the min stack. Let me see how that... Yeah, okay. I guess I wonder if there's any extra edge cases like that. I could try and think about it, or I could submit and then think about it. No, there wasn't. Okay. I'm actually surprised I came up with that fast. I almost gave up, but that's why I make these videos, so that doesn't happen during the interview. Wow, holy shit. Imagine practicing the thing you have to do helps you at that thing. Wow. Alright, until next time, goodbye.